Okay, anybody hearing me? Hopefully somebody will hear me eventually. So what we're going to do is we're going to cover the release of the Atlas 3i images. Got about 18 minutes to go. Just wait a second for you guys to see if anybody show up. Mikey. So, okay, we got about 16 minutes to go before the press conference starts. Please give some time for people to come in. Maybe talk about Mikey for a few minutes while we're waiting.
Good day, folks. Good day. Good day. For those of you, whatever. Okay. Enter screen. This one. We're just gonna continue on. Shh. We're just. Oh, be very quiet. Be very quiet. Be very sneaky. Sneaky, sneaky, sneaky. Okay. We're gonna go over here. And we are going to do what? I have no idea because how about we just sit on our asses today? Oh, I can't stand it. I can't stand this place we live. I think I'm done talking. I really am, guys. I'm just going to sit and listen to the bullshit that's being told to me. Anyways, we got to play a video here if it matters. What do I got to do? I guess I got to go to YouTube. All right, guys. Tell me what to do because whatever. I don't know. Anyways, I went to go see my lawyer yesterday, and that's all that matters. Ha! So what? Oh, shoot! I shouldn't have said that. I have to keep it a secret now. I'm gonna keep everything a secret. Yes.
Often when we're trying to tell them stuff and do stuff, it's trying to help them a bit. But I'm going to say something here. One reason that I keep an eye on Mikey is I used to work at a call center many years ago. And at the call center, we get like practical jokers and people calling in for all kinds of crazy reasons. And Mikey's cold calling, plus I worked at an observatory, so him calling observatories and bugging them, and just general being a pest for both sides kind of irritates me. At the call center, you get a lot of kids doing practical jokes, and you get a lot of lonely guys. If you catch my drift. And well, since I'm the guy, they didn't want to talk to me. All you hear was them hanging up. But for the rest of the night, you hear the girls talking about this guy calling in. So I've got a couple of reasons to keep an eye on Mikey. So hopefully somebody will pick up on the stream. In a few minutes, we'll it's 3 p.m. 3 p.m. Eastern or 4 p.m. Atlantic time. They're going to start showing images of 3i Atlas. So I'm just filling in some time here.
Actually, I didn't go see my lawyer. I didn't go live yesterday, and I didn't do a few things, but who cares? Nobody really cares. Oh, okay, so let's move on to some videos, I guess. I don't know. Frick, who really cares? Dishonesty, I can't stand it. I can't stand it. Anyways, let's Woo, cuckoo, cuckoo, cuckoo.
Okay.
What's the next one? I have a job. Okay, that's another excuse. If you, why can't I get this thing going? Well, maybe I'll just turn my stupid phone on and wait for the 15 messages to come through. You know, I don't get it, man. Like, seriously, tell me what you guys are so excited about on when you go live. I detest sitting here. I'm not doing anything right now. I'm not doing. What am I accomplishing right now? Seriously. I can show you some more firmament pictures because that's what the hell I do. And yes, the firmament is real for those of you who do not know that it's real. This is not my opinion. I have taken many, 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 many pictures.
Yeah, this is from the live stream earlier. Here's the thing. Why I'm live is there's Atlas images that you're going to be seeing, and maybe talk a little bit about some of the crazy theories I've seen online about Atlas. But 3i, it's not 31, it's 3i. But some people just like socializing on the internet. That's why a lot of people stream. It's a social thing for them. Some people are not that social, so in real life, so they get a chance to be social online. That's it. That's it. But that's the thing. Plus, right now I'm trying to figure out how to do a couple things logistically. So.
And videos of the firmament. It's not hard to do. You just have to use this instead of these. Okay? Turn your computers off and your phones. Go out. Talk to your neighbors. Because I can't do this by myself. And yes, I am doing this by myself. Does that bother you when I say that? If you think I'm wrong with that statement, go out and stand on the corner with a sign stating that space is fake, the moon landing's fake, something.
No, I won't do any of the things because I know none of it's fake. But he thinks going out in public and standing with a sign just makes people think that those things are fake. It just makes them make fun of him. But okay. But that's okay. I don't know. We'll let him talk a little bit more. Fill in some space here.
Well, Mike, I can't do that. I have a family. Okay, excuse one. What's the next one? I have a job. Okay, that's another excuse. Number 3, keep them coming. Come on. We all do flat earth in our own ways. Okay, that's number 3. I don't know what the fuck that even means because nobody's doing anything about it.
My reason to watch them is to try to keep people from falling into the trap of flat earth. So.
Flat earth. They're just gathering on the YouTube channels and doing nothing. No idea, guys. I have no idea what the purpose of your YouTube channels are. Okay? I have no idea whatsoever.
Okay, I'm going to talk about the 3i Atlas, and there are. This is actually more useful, and 3i Atlas has been called all kinds of things, a spaceship, and it's been breaking up. I haven't seen the real observations, but some people are saying comets breaking up. Here's the thing, comets break up all the time. The most notable one was Shoemaker Levy 9 in 1994, but they break up all the time. And then you have Abbey Loeb I just okay. Abby Loeb thinks it's every interstellar comet is a UFO. Um, he I read his basically an autobiography called Extraterrestrial. It has a lot about his life in it, and he goes on about and how he came to be doing 3I Atlas material. He started off doing physics, plasma physics for basically the Israeli Defense Force and the U.S. Army. In the 80s, there was a project called Strategic Defense Initiative, SDI, otherwise known as Star Wars. And this was a way of shooting down rockets, nuclear rockets from Russia headed to the States. And Avi Loeb worked on one of these side projects and got money from it while working in Israel for basically his undergrad. And then he, I think he had a PhD, but he went to a bunch of conferences in the States and got into doing astrophysics at Princeton's Institute for Advanced Studies. This is where people like Einstein worked, and Richard Feynman got his degree from. Richard Feynman, when he was a young guy, had to go up in front of Einstein to present a paper. Now that's not intimidating, but Avi Loeb went there and started studying black holes and stuff. So I don't think I don't think he did much astronomy on the undergrad level, and then he had to catch up at the grad level and postdoc level. And then he's done a number of projects dealing with space and black holes and stuff since. So now he's going around saying this is a interstellar spacecraft because it'd be impossible for stars to eject material like 3I Atlas into space. Sorry for the 3A stuff. I don't know why that's happening, but every time. But he worked on some solar sail research, and he had somebody worked with somebody about asteroids, for a couple of papers. But I don't think they. Here's the thing: in astronomy, there's tons and tons of papers being published a year, and it's hard to keep up. And I don't think somebody didn't keep up on the papers because there are ways for asteroids to start off in the inner solar system at the beginning of creation of a solar system. A planet like Jupiter can get an orbit around a planet like Jupiter and get slingshot out to the outer parts of the solar system, and maybe another star comes by and it gets ejected that way. Or so there's plenty of ways these things get ejected from solar system. So when Oumuamua and Oumuamua he thought was a UFO, and I think Borisov for a while he thought it was a UFO, but he did some things like he went to the South Asian Ocean because he thought these little spikes and seismographs were pieces of the UFO crashing into the Earth, and they were just pieces of iron, or they're actually those spikes on the seismograph are more likely trucks passing by the seismograph. But he found some iron nodules out in the ocean, and took them home without appropriate paperwork. But he's just caught up in the idea that this is a UFO. I don't think he's really out for making money off of it. I think he really thinks that these are UFOs. He has some religious reasons for believing it. But I don't think it's I think it's considered a pious fraud. He honestly thinks this is happening. He's not out. This is going to be a stretch, and people are going to probably be upset with me. he's a bit like Mikey. Mikey thinks he's doing good astronomy observations, and Abby Lopes thinks he's doing good observations, and they both honestly think they're in the right. So, so 3 minutes to go. Watch on NASA TV. I don't think Abby was doing it for out of greed or anything, but so we'll just wait here for a few more minutes. Nope, no longer Mikey. There we go. 2 minutes left. So I wish other people were in here chatting, but it's an odd time. So this is the problem with a lot of these press conferences. They're when everybody's either at work or going home from work or going to work. But I think it's just going to be images of comments. There's been some other goofy ones online. It's all kinds of silly things. But okay. I'm just going to check something on my channel while we're waiting. A few views. This is MSA 41 or NGC 2287 and okay, it's starting to do better. And thank you for anybody who did who has subscribed to my channel. I don't do the usual like, subscribe or share because I figured if you're watching it, you probably know to do that if you wanted to.
Find the shade.
Yes, it's starting on NASA TV now. So here we go. Yeah, sometimes it takes a while for them to get everything set up. They're compressed. Who's around? not seeing anything in the chat. So I've been having some issues with OBS, so I'm not seeing it. Hello, everybody. Kind of odd to streaming somebody else's material. Hopefully we'll get some commentary. It should be pretty cool. What kind of stuff? What observatories they used to get the better news. The thing is, it didn't really get posted. The one thing that everybody's like, well, it looks smaller further away. Well, when it's further away, you probably don't get a good angle on the objects. Well, that's one reason why it looks bigger is it came closer to the Earth than to the other solar system. Plus, a lot of them are going, well, this doesn't have the typical stuff that our solar system has. Well, it's extra stellar, so it probably has a different star system. It probably has different concentrations of material. That's the basic parts of it. It's not some alien spacecraft. We'll just wait and see what they have to say once they get everything set up in their place. It can be a little difficult with these things. If you wonder, try to have this wrapped up before 6 o'clock in 2 hours. streaming for astronomy, you don't get a real predictable schedule. You have something weird happen, and then they have a press conference, and they launch a new telescope and watch it. Probably every 6 months, or every 6 days. So, I need to get the hours for the YouTube system. You need about 3,000 hours to get monetized on the first one. And about 500 subscribers. I'm not doing too bad on the subscribers. Since a lot of my stuff is shorts. There's nothing to do with the next one. So, yeah, we're still waiting here for him. Okay, this is I'm just going to refresh and double check. Okay, everybody.
Find the shade.
No. Let's see if we can find some 3i and stuff. Conspiracy things.
Very strange things are being said about Comet 3i Atlas, that it looks like an alien spaceship, that it is huge, that its trajectory is perfect for spying on the solar system, that NASA is hiding it and it has just passed by Mars, and we have this photograph from Robert Perseverance. Or at least that is what we believe, because NASA has not said absolutely anything, nor has it released any statement. They are completely silent, and this has fueled all kinds of theories that NASA is hiding it. But there is a reason for all this, I will tell you. Let's see. 3i Atlas is the third interstellar object that has ever been detected, which means that it comes from outside our solar system. This is the trajectory that it follows, which as you can see takes it close to planets like Jupiter, Venus and Mars. Some say that this trajectory is perfect for spying on the solar system, but honestly to me it seems super random and it does not even pass by Earth. With this, by the way, we also rule out the people who say that this comet is going to impact with the Earth. That doesn't make any sense, and as I've already told you, a few days ago it flew past Mars and supposedly the Robert Perseverance took this photograph of it, and of course, all hell broke loose. What's going on? Is it an elongated object? Well, no, this is probably the result of stacking different images taken consecutively. And since the object was moving between one and the other, In the end, the result of stacking all those images is this elongated object. But do you know what's happening?
Okay, that's a conspiracy theory. But the thing is NASA likes to study things before releasing it. Before releasing details.
NASA has snapped a rare space close-up, the clearest photo, in fact, ever taken of an interstellar comet. Comet 3I Atlas was captured racing through our solar system at about, 210,000 kilometers an hour. Astronomers say this originated from outside our solar system, making it only the third interstellar object ever discovered. NASA says it is passing safely at a distance of about 274 million kilometers from Earth.
Nothing really. You could make an inside joke about the tech team at NASA. I'm wondering why.
So that object was moving nearly twice as fast as previous things in space. So what made the speeds and size so remarkable to what we've seen in the past?
Well, first thing, it implied that it came from outside the solar system because gravity cannot bind it to the sun. It was moving too fast for that. And the other thing is that the object was relatively big, possibly tens of kilometers, the size of Manhattan Island. And if that's the case, it was 1,000,000 times more massive than the previous objects from outside the solar system, and that was puzzling. It also came in the same plane as the planets around the sun, within 5 degrees. And the chance for that happening at random is 1 in 500. And then when we obtained the best image of it, it looked as if there is a glow ahead of the object towards the sun.
The glow ahead of the sun could be just a jet heavier material. Like the sun has a solar wind that pushes the material backwards. It's not that strong, but there's a stream of particles. And if you have a heavy nuclei like nickel or iron or something like that going towards the sun, it takes a lot of that solar wind to push it backwards. That's why there's a jet ahead of it.
Instead of the typical tail that we see behind comets away from the sun. And that glow was cigar-shaped. It was 10 times longer than wide, and it's just not clear what this object is.
The glow on this image, which we're not exactly sure exactly what it is that what is leading to maybe this theory that some people think that this could be an alien ship?
Well, it's a possibility.
Catch the latest on this story at Fox 30.
An unprecedented innovation, a culinary revelation, the opposite of anything you've ever tasted. The J&PB. Try it for the first time, only with Smucker's Jam.
Okay, why am I not having a live stream?
Excited to help share them with you today. This is a new scientific opportunity, and it's a new window into the makeups and histories of other solar systems. We're just beginning to learn about these types of objects and figure out what. We organized a workshop, we organized a coordination session for the missions across the NASA fleet that had good opportunities for potentially observing 3I Atlas so that we could all share observing plans and knew what was going to be possible with our assets. I can't emphasize enough now how, thanks to the cooperation of so many mission teams, we will be accumulating a wealth of data on this comet that the science community will be digging into for years. Now, let's go back to September, and I can show you a sampling of the images collected by our different mission teams. To set the context, you're going to see a comet that's a small body with a coma around it, basically a fuzzy blob. Now remember, space is big, nothing is ever really as close as you like, and all of these observations are very, very difficult. It's a little bit as if our NASA spacecraft were at a baseball game, watching the game from different places in the stadium. Everybody's got a camera and they're trying to get a picture of the ball, and nobody has a perfect view, and everybody has a different camera. Now, let's return to September and see the first images from the Psyche spacecraft. NASA's Psyche mission acquired 4 broadband black and white images of the comet over the course of 8 hours on September 8th and 9th, 2025. The comet was about 33 million miles from the spacecraft at that time, and you can see in the image the large frame where the comet was seen at different times. Down in the bottom left is a blow-up, a stack in addition of all of those observations. The Psyche spacecraft is on its way to an asteroid in the main asteroid belt that's also named Psyche, and these images were the first captured from this perspective. Now, if you think in that lower left you're not seeing very much, just wait a minute, you'll see more. Now, the following week in September, the Lucy spacecraft observed the comet from the opposite direction. So let's take a look at the Lucy image. This is another broadband black and white image made by adding up a series of individual exposures that were taken on September 16th. Lucy is on its way to study asteroids that shared Jupiter's orbit around the Sun, called the Trojan asteroids. Lucy was 240 million miles away from 3I Atlas, which is circled in the center, when its high-resolution LaLaurie camera caught the comet. You can see the comet's coma, the fuzzy halo of gas and dust surrounding 3I Atlas, and its tail, a smudge extending to the right of the comet. If you were the Lucy spacecraft looking at the comet from this angle, the sun would be a little bit over your left shoulder, and so the comet tail is pointing away from the sun, as we've seen many times before in solar system comets. For scale, this image spans about 1/3 the width of the full moon as you'd see it on the sky. Of course, at the distance of the comet, that's a much, much larger region of space than the moon. Now, this looks a little different from the Psyche image. Part of that is because the cameras are different, and part is because of the ways the Psyche and the Lucy teams decided to show their images. But also, it's because we're seeing the comet from different directions. Seeing a comet's coma in different lighting geometries, with the sun coming from different directions, is one of the key ways to learn about the physical properties of the dust that's been launched off its surface. And I want to emphasize that you do not get these views unless you have spacecraft farther from the sun than the comet is, so that you can see it backlit. We could not get this view from the vantage point of the Earth. So combining the data from Lucy, Psyche, and Earth-based telescopes, scientists are hoping to better understand both the three-dimensional structure of the comet and the nature of the dust. It's a rare opportunity to compare ancient dust from a distant solar system to that from our own. Now let's go to the next picture from the MAVEN spacecraft at Mars. At the beginning of October, 3I Atlas passed within 20 million miles of Mars, which gave our Mars spacecraft an opportunity for a close-up. And earlier you saw the image that Ahmed shared from our Mars Reconnaissance Orbiter. MAVEN is another Mars orbiter that has been studying the Martian atmosphere since 2014. Now, this picture is not a direct picture of the comet itself. It's a spectrum. You're seeing the science wiggles that Sean was just talking about. This is some of those science wiggles where the instrument, the spectrograph, the ultraviolet spectrograph on MAVEN, has looked at the comet and also split up the ultraviolet light according to color. So you're seeing 3 different bands in this image. On the right, you're seeing emission from hydrogen gas in the atmosphere of Mars. In the middle, there's a fainter band indicating that's coming from hydrogen gas in interplanetary space. And on the left, that blob is the signature of hydrogen gas coming from Comet 3I Atlas. It's a little blob rather than a big streak because the comet is a small object in the sky relative to great big gigantic Mars and interstellar space that fills the entire field of the instrument. That definitely tells us, first of all, that the comet is there. If there were no comet, there would be no little blob on the left side of the image. But it's also telling us it's one of the many ways that we're able to discern the chemical composition of 3I Atlas. And in this particular example, it's showing us the hydrogen gas that's coming off of the nucleus. Now, MAVEN's observations, combined with the earlier observations by Swift and Webb that Sean spoke about, will help determine the water production rate, how much water vapor is released from the comet when the comet is warmed by the sun, which provides insight into the formation of the comet and its journey through our galaxy. Now, the European Space Agency and NASA's Solar and Heliospheric Observatory, or SOHO, also successfully imaged 3I Atlas from October 15th to 16th after it had passed Mars. And SOHO spotted the comet crossing its field of view from approximately 222 million miles away, or more than twice the distance of Earth from the Sun. Comet 3I Atlas was expected to be too faint for SOHO to see, but this result was made using detailed image processing and overlaying, or we call it stacking, subsequent telescope images. And this image highlights the value of spacecraft and instruments designed to look directly toward the sun, as Nikki was saying before, not only to study the sun, but also to have the ability to see other objects crossing, in this case, behind the sun from the telescope's point of view. You'll be able to see the rest of the images on our 3I Atlas website, go.nasa.gov/3I-Atlas. And there will be more to come. Not all of the data have been downlinked yet through NASA's Deep Space Network, and there are more observations still in work. And also, it's a long way from where we are today, seeing the initial images, to then making sure that they are accurately calibrated and processed to do science with, and then doing the analysis, combining the data sets, understanding them, and finally producing the scientific understanding, the knowledge of what this all means, which will be published in peer-reviewed scientific journals. But the answers will come later on. We are still at this phase, very much in the state where we're figuring out what are even the right questions to ask about interstellar objects. This is a snapshot of where we are very early in the scientific process. Okay, back to you, Courtney.
All right, thank you all for your opening remarks. We'll go ahead and start the question and answer portion of this event. Just a reminder to our media on the phone bridge to press *1 to enter the queue and ask your questions. We'll take our first question from the phone bridge from Marcia Dunn with the Associated Press.
Yes, hi. Based on your latest observation, what more can you tell us about the potential shape of the comet? Can you fine-tune any more on how big or small it might be, origin, all that sort of thing? Thank you.
Thanks for that question. There's a lot of territory to cover there, so let's see what I can do. The size of the nucleus still has yet to be pinned down. The best data are still from the Hubble observations that Sean was talking about. So we're still right now in that range of somewhere in the vicinity of a couple of thousand feet to a couple of miles diameter, but we'll get better on that one. The shape of the nucleus is also difficult to pin down because generally we're not resolving it in our observations. It's obscured by the dust, and especially it's obscured by the reflected sunlight off of the dust in the inner part of the coma. But what observers from the ground have been able to do is observe the brightness of the center of the comet over time to see if there's a modulation of that brightness that would be an indication of rotation. And it's very difficult to discern. So what it's looking like so far is that there's not a big, the shape of the nucleus is not very far from being round. Doesn't seem to be a big, or at least we're not seeing signatures of a very elongated object yet. There's a lot still to come there. I think you were also talking about origin. It would be great, it would be fabulous if we could trace back the incoming trajectory into the solar system and trace that back and figure out where it came from. But things are not quite so simple. Our galaxy, as Sean knows, is a big and complicated place. And the sun and all the other stars in our galaxy are in orbit around the center of the galaxy. And so 3I Atlas has been in interstellar space for a very long time. There is circumstantial evidence, given how fast it has come in to our solar system, that it came from some very old population, of solar system around a very old star. Quite possibly, we can't say this for sure, but the likelihood is it came from a solar system older than our own solar system itself, which gives me goosebumps to think about, frankly, because that means the 3I Atlas is not just a window into another solar system, it's a window into the deep past, and so deep in the past that it predates even the formation of our Earth and our Sun.
All right, we'll take our next question from the phone bridge from Bill Harwood with CBS. Bill, if you're talking, we can't hear you.
Try me again. This is Bill Harwood again. Can you hear me?
We have you loud and clear.
Okay, thanks. Sorry about that. Amit mentioned the rumors that were, kind of scurrying around about this thing in the weeks leading up to this briefing today. I have two questions for anybody who would care to answer. One is, did any of you seriously, did you take seriously the proposition from some that this could be an alien spacecraft?
No.
I doubt you did, but I'm asking the question anyway. And number two, is there any evidence you see in any of the data you have that would fit an explanation like that? Or as far as you're concerned, does all of the data say conclusively that this is simply a comet that happens to be passing through the solar system? Thanks.
So I'll take that one, Bill, and thanks for the question. We love all of the different science and all of the different kind of hypotheses into what these things can be. When you start seeing something, you just got to point. It's natural to wonder what it is. And we actually love, as Amit said, we love that the world wondered along with us. And that's such a cool thing. We certainly were able, because of the measurements that Sean described from the astrophysics telescopes that immediately turned on this object once we found it. And even, I was interested, I just learned that we'd actually gone back and actually seen it before we even found it. So that was super cool. I just heard that from Sean. But, we were very quickly able to look for sort of, the easiest thing to do, I'll put it in a different way, is if you understand comets pretty well and you understand asteroids pretty well, you kind of know the signatures that you're looking for, and so you can sort of look for those quickly and tick them off and say, yep, it really does behave like a comet. The interesting thing that, Tom, I know if I throw this to him in a second, he's going to geek out about it. But the really cool thing about this is the differences, because it comes from somewhere else. And that's why we're so excited about it. It's only the third time that we've been able to identify and track something coming from outside our own solar system. We've long predicted these things occur, and now, of course, we know better how to look for them, and we now have this amazing Atlas array. We're expecting we'll find a lot more of them, but it was quick. We were quick to be able to say, yep, it definitely behaves like a comet. We certainly haven't seen any technosignatures or anything from it that would lead us to believe it was anything other than a comet. But the super cool thing is not that it's exactly like all the comets that we see in our solar system. It's the differences that are so tantalizing for us as it gives me goosebumps too. It could be from something that existed before our own solar system. That is so cool. It's from something that predates even our own star. Yep, it's going to look different because it didn't come from our solar system, and that's what makes it so magical. You want to geek out a little bit, Tom?
You were geeking out so expertly, Nikki, to begin with. So that was fabulous. But that's exactly right. I mean, things from other places, we naturally expect them to be different from our own homegrown variety. And I like to imagine if if you're fortunate enough to have grown up in Hawaii and you only drank Kona coffee, you love your Kona coffee, and then somebody says to you, well, gee, have you tried Sumatran? You're going to say, well, do you expect it to be different? And they'll say, why don't you try this? And you try it and you say, wow, that's really different. And you realize, well, I expected this to be different because it was from someplace else. It was a different environment in Sumatra. Now, does that one sip of coffee tell you everything about the weather in Sumatra and the soil and the people who harvest the coffee? Bless them. Of course not, but it's different, and yet it's still coffee. And that's what we have in this case. We have a cometary body. It behaves, it resembles the homegrown comets that we have in our solar system, and yet it's excitingly different in particular ways. It does the same thing comets do. It evaporates carbon dioxide gas. It evaporates water. But it's evaporating more carbon dioxide compared to water. So that's a very interesting thing. Comets evaporate dust, and the dust is broken down. The minerals are broken down by the ultraviolet light of the sun. And comets, we know comets put out nickel, they put out iron. That's what comets do. This particular one is putting out more nickel than iron. That's really interesting, really remarkable, and something to be studied in the future. So we're always interested in new ideas. We're always interested in new suggestions, and all ideas are good when they're born. But those that stand the test of time, those that stand up to testing, those that are supported by the evidence, are the ones that survive.
All right, we'll take our next question on the phone bridge, and that one comes from Matthew Glasser with ABC.
Good afternoon. Thank you for doing this. Tom mentioned that the answers will come in time. I'm curious about what are some of the hopes that we might discover from this comet. What might it tell us about our planet, about our solar system, about the universe? Are there key things you're looking for as you start to analyze this data, and are you excited about anything in particular when it comes to better understanding how things are working out there?
Sure, I can take that. Every new object we discover is a new piece in the puzzle. What we're trying to do always is to understand the universe. That's part of the NASA mission, is to understand the solar system, understand the universe, understand the origin of planets, the origin of life. And that is a huge question, and we get little bits, little clues to parts of that puzzle, and we start trying to put that puzzle together. We have gained tremendous amount of information from hundreds of years of astronomical observation and from decades of in situ spacecraft observation has revealed our planets as actual places, not just points in the sky that you could barely see with your own eyes. We've learned about comets and asteroids, and we're beginning to put together a picture of how all of those planet-forming minerals and planet-forming ices came together to form our planets, and how our solar system changed over time. Just one example, we get a fascinating clue from the objects like Pluto that we've been discovering since the 1990s, the trans-Neptunian objects. The way they are distributed through space in the outer solar system show us clues to how the orbits of major planets may have changed over time in the early solar system. A fascinating thing, and questions that we would never have thought to ask before we knew about these trans-Neptunian objects. Now, interstellar objects, like I said before, are new windows, and it's windows that we've never even looked out of before. So what we're going to find is way too early to predict, but I think we're getting a hint of the breadth, the wide spectrum of conditions that existed in different parts of the galaxy, in different solar systems, where the compositions, the elemental abundances, the mineral abundances may have been very, very different. It would be a different picture if we were seeing the first three interstellar objects and we'd say, gee, those look exactly like our homegrown comets. That would have been really interesting, and we would have said, well, maybe our galaxy is a boring place because every place is the same. What we're seeing with this is not every place is the same. That's a good thing. Lots of places to explore, and they will be different if we ever manage to get there.
Yeah, I think of these as frozen fossils from their moments of formation, including the things in and now from beyond our solar system. Or in some cases, we point our telescopes at other debris disks, which is just, a whole system full of these small bodies. And so now what this will let us do is tell that story in a broader context, between the detailed and large library of data we have on those origins of our own solar system and how volatiles were delivered to make life possible here on Earth, combined with that big picture of other systems, of the dust spread throughout those other solar systems. And now with this visitor that got frozen in time from somewhere beyond our solar system, and that small picture of what that was like when that formed.
And the fact that, I love the sort of thought of it as that frozen fossil, almost frozen time capsule. We're kind of privileged. I mean, it's come into our solar system, our sun. We know, we think it hasn't seen a star for a long time. So it's actually warming up and giving us more information. It isn't just about a frozen object coming through and us sort of saying, oh, look, there's a frozen object moving through. But as it's almost waking up and showing us its composition, and that's allowing us to be able to do this great science. If it had just remained frozen all the time, we wouldn't know much about it. But it is the sort of its rendezvous with our star that is allowing us to really do this amazing science. And that to me it makes me feel almost privileged to actually be able to unlock the secrets as this cometary object is coming around and rendezvousing and interacting with our solar system.
All right, let's head over to social media. Nina on X asks, will it hit any planets in our solar system?
No, it will not. I think if you, obviously we're not going to run it again, but please, go online, take a look at go.nasa.gov/3i-atlas and take a look at the trajectory. I kind of talked through it briefly. Tom talked through it, and you can sort of see where those planets are. And remember this, even though it's exciting and it's coming through, space is huge, as both Sean and Tom talked about. And so the probability of it actually hitting anything is super, super small. You have to have all these things aligned to actually be able to do it. But certainly the objects in our solar system will be just fine.
And we have another question from social media from Astronomeum. They ask, what makes Comet 3I Atlas so different and intriguing compared to the other interstellar comets?
Tom, you want to take that?
The other interstellar objects. We say interstellar objects because not all of them were comets. So the first one was discovered in 2017. That was 1I Oumuamua that behaved very much like an asteroid. Again, a little bit like 3I Atlas, a very interesting asteroid, in some ways different from the asteroids we're accustomed to seeing in our solar system. For one thing, it was seemed to be very, very elongated, and while it was inactive, it seemed to be an inert, mostly rocky object. It did show indirect indications that it was evaporating gases in some way. It wasn't around long enough for us to get really, really comprehensive long-duration observations and understand exactly what it was doing. It was the very first one. We saw it for a short time when it was on its way out, in fact, and so we didn't get a great view of that. The second object, 2I Borisov, discovered in 2019, behaved, it was a comet. It was definitely a comet. It behaved in a lot of ways like our homegrown solar system comets, in many ways like 3I Atlas. Its properties were more in line with what we're used to seeing, and the comet observers regarded it as very much akin to our solar system comets, although in some ways a little bit at the edge of what we're used to seeing. 3I Atlas is in a lot of ways like 2I Borisov, but a bit more out there in terms of things like the carbon dioxide to water ratio.
All right, Svetlana on LinkedIn asks, will the observational data from this campaign be available for open analysis?
Absolutely. Every piece of NASA data, we are delighted to share. We've had open data policy at NASA for a long time. We make a big effort not just to release the data, but also to make sure it's usable, so you can get the tools and things to actually analyze the data as well. And we invite everybody to look at this comet with us. If you're able to take your own images through like citizen science programs, we love that too. We love everybody to be sharing in the joy of NASA science as we take every opportunity to take advantage of these incredible visitors to our solar system.
And that citizen science campaign, that includes work that citizens help us do to identify small bodies in our solar system. And so if you really want to get engaged beyond just looking at the data, you can help us generate new data and find other objects for us to study.
Yep, the big one, our solar SOHO, big comet finder, big comet tracker. So many of those comets discovered by our citizen scientists. So keep those observations coming.
All right, we'll head back over to the phone bridge. Our next question comes from Ken Chang with the New York Times.
Hi, thank you. This is for Tom and Nikki. One, of the measurements made so far, what is uniquely different about this comet, other than the trajectory, of course? And two, since perihelion, it looks like there are multiple jets. I was wondering if you could talk about that and the speculation that it might have exploded. Thank you.
Yeah, thanks, Ken. So some of the differences I already mentioned is the ratio, the carbon dioxide to water ratio, the nickel to iron ratio. Also, there were ground-based observations noting that the polarization of the light reflected off the dust was also unusual, so that's telling us some interesting things about the dust. There are other indications that the physical properties of this dust, maybe the grain size distribution, might be different from the sorts of things that we're used to. The appearance of a sunward tail early on in the trajectory was part of that, an indication that the dust was being pushed off the comet on the sunward side, and then it took a while for the solar radiation pressure to push it back the other way. That's been seen before in other comets, but not very often. I'm sorry, Ken, what was the second part of the question?
Did it?
Perihelion.
Yeah. The jets, right. So seeing activity, seeing more activity are in the inner coma around the nucleus right around the time of perihelion, when it's being warmed most intensely, is something that happens frequently. That's something the comet observers are going to be very, very excited about. It does take some time to figure out, because it takes time for the actual event that happens on the surface to propagate out to a distance where you can see it with the telescope, but people are going to be mapping what jets there are. It doesn't necessarily mean there was an explosion. Jets can also just mean there are particularly active areas on the surface of the comet where more volatile stuff is evaporating in that one spot than elsewhere and jetting out. We saw this a decade ago with the ESA Rosetta mission at Comet 67P. It got up close and personal with the nucleus and saw frequently that there were jets coming out from specific places on the nucleus of the comet. So that could very well be what's going on here. Can't tell for sure, but that's the sort of thing we've seen before.
The other thing I just want to say that we're expecting to see as more stuff gets thrown off this comet in these jets is at those warmer temperatures, additional things can bake off of it, additional gases can bake off, and so we do expect the composition of the coma to potentially change, or those jets to change over time. And looking at the details of what other molecules we detect beyond the carbon dioxide and water we mentioned is also going to be interesting, especially for that sort of like, what was the area in this, what was this stuff made of in the area it was made, like long time ago.
Our next question is from David Chandler with Sky and Telescope.
Yes, a couple of things. Have you any of these observations showing you anything about any non-gravitational accelerations at this point? And also, can you say a little bit about coming attractions? What observations are in the pipeline that have been made but not released yet? I think the MRO high-rise observations, has that been released yet? And what else is there that's either in the can and waiting to come out, or observations that will be made over the coming weeks as the object comes closer to Earth?
Mm-hmm. I can answer some of that about the non-gravitational accelerations. This is something that we look very closely at for every comet, because that's always something that happens. And just to back up to explain what the question is that as comets evaporate, they are blowing off gas, they are blowing off dust, and every time something gets pushed off the comet, that acts like a little rocket engine at that moment and pushes in the other direction. And so it's very, very common to see comets have subtle changes in their orbits as a result of these little rocket forces, just called non-gravitational accelerations. So this is being monitored very closely. I spoke to our orbit determination team of the Jet Propulsion Laboratory earlier this week, and what they said is that this is being monitored. There are some changes to the orbit, but the uncertainties are still fairly large. It's difficult because we can't see the nucleus directly. It's difficult to get a very, very precise track on exactly where it's going. But so far, the non-gravitational accelerations have been very much on par with the sort that we see in solar system comets.
In terms of future observations, this is a situation where, because this is only the third time we've had an opportunity to look at an object like this, everyone that is in control of a telescope wants to look at it because it's a fascinating and rare opportunity. I know that our colleagues from the Keck Observatory have looked at it. I believe that we're going to look at it again with JWST in December. We have some other ground-based facilities that are giving us additional compositional information as those additional molecules bake off of 3I Atlas. Those are the things I'm aware of. There's probably a lot more that I'm not, because like I said, like every astronomer wants to get data on this thing because it's such a rare opportunity.
Yeah, and the HiRISE image that you asked about specifically, Amit kind of rolled that out at the beginning. So please take a look at that image. I think Sean is not bragging a lot on what these astrophysics telescope. I don't know why, but because we are able to look at it in infrared with the James Webb Space Telescope, that will be the last time we can see the comet. So as it is exiting the solar system and getting further and further away, the James Webb Space Telescope will actually be able to track it longer than anyone else, partly because of its ability to kind of look long and deep, rather than sort of across and wide, and the fact that it looks in the ultraviolet, in the infrared, so it can kind of see the dark objects. And so I'm really excited about just sort of, tracking it to the very end. Also noted we're downlinking data from missions. I mentioned Parker Solar Probe because I just heard before we came on that we'd got some data and we'd seen the comet. I haven't had time to look at the data yet, but all of those things are coming up as we are getting more and more data coming down to us from those missions. And then as both Sean and Tom talked about, just really making sure we're sharpening up those images and really making sure they're calibrated. Right now we're putting out almost the raw images. We're putting out things quickly so everyone can see them, but we'll take some time and do some real sort of deep looking into those and do some more of the spectroscopy. Tom showed a really great example of kind of looking through the atmosphere of Mars, take out that hydrogen, take out the hydrogen from our solar system, and then let us look at the hydrogen that's coming from the comet. So we'll be doing a lot more of that as we move on to do great things with NASA science.
All right, that's a great lead into our next question on social media. Elijah on X asks, what kind of processing were the images subjected to and why did they need it?
Want to take that?
The images that were released received the sort of standard processing that we do between the raw data that comes down into a telescope. That, as Nikki said, we need to make sure for scientific accuracy that they're calibrated against the other observations, and we account for anything that the telescope is doing in that moment. And so that it would be our standard set of calibrations and normalizations for a object of this type, which is to say a comet.
I can add a little bit more to that. As Nikki said, our desire was to get these images out to the public as quickly as possible, and so there are some image artifacts in there that you'll see, and I can speak to the Lucy image that you saw previously. If you look at the comet, you'll see some blobs around the comet. Little blobs, faint blobs around the comet are not real. It came from the fact that in order to get this particular view, it was necessary, which is this backlit view, the team had to turn the spacecraft to face more toward the sun than it generally does. And so that means some part of the spacecraft were in the sun, and some of that bright, the sunlight reflected off parts of the spacecraft got into the camera, and that resulted in those little blobs. So that's an example of processing that has yet to be done to figure out exactly what that scattered light contribution was and remove that from the image so that what we show in the image is entirely what was there in the sky and not something just made by sun glints off the spacecraft hardware.
Yeah, and sometimes I think you showed the SOHO image where we actually stacked a couple of images because a single image you wouldn't be able to see it would be too faint, but if we stack a couple of images together, then you can actually start to really make out what that comet looks like.
Okay, next, Gail on Facebook asks, how can an object like 3I Atlas come from so far, moving as fast as it is, and not hit anything?
Space is
Orbital
very
dynamics and space is really, really huge. And so, even it is amazing to think about just how big even our solar system. And so to give you the Voyager spacecraft, Voyager 1 is now 1 light day away from Earth, which means when we send a command or we send a photon from Earth, it takes a full day for that photon to arrive at Voyager. And Voyager is only just outside kind of what we think of as the edge of our solar system. And so space is vast. Yes, this thing is moving quickly, and yes, it came from outside our solar system. But the probability of it actually hitting something is so small, because everything has to align. It's also not quite in the ecliptic plane. It's not quite in like our normal. If you think about sort of looking side on at our solar system with the sun, and then you put the planets kind of in a row. Normally, everything sort of orbits in this plane. This is slightly tipped. Not unusual because it's not gravitationally bound to our sun, but it's slightly tipped. That makes the probability of it hitting it almost even greater.
If I can play with a scale model solar system. If you make a scale model solar system where the sun and the Earth are 1 foot apart, and that's about 1 foot. The sun is a P. The Earth, you need a magnifying glass to see, it's so small. The entire solar system will just barely fit in your house if you squeeze a little bit, and the next nearest star is over 50 miles away. So they call it space for a reason. Most of it is space.
Okay, we'll head back to our phone bridge. Our next question is from Brandon Spector with Live Science.
Hi, I wanted to ask about the age of the comet. You mentioned there's circumstantial evidence that it's much older than our solar system, but how can we constrain that age a little more, and what will that tell us if it is indeed much, much older than the solar system?
I can start that, but I'm going to pass it to Sean to talk about ages in the galaxy.
Okay.
So cutting to the end, the bottom line is going to be, it's probably going to be really hard to get a more precise figure from one object. I think what we're looking at in the future, as we discover more of these, when we get to the point where we have maybe a few dozen of them and look at the distribution properties, we may be able to get a better handle on what the distribution of ages is. So what's going on here is that it takes the sun 240 million years to orbit around the center of the galaxy, and we're doing that with a neighborhood of stars. So we're all going around the center of the galaxy. The relative motions between stars in our solar neighborhood is sort of 10-ish, 15, and sorry, I have all these numbers in my head in metric because that's the way I learned them, but 10 or 15-ish kilometers per second. So what is that? That's about 25,000 miles an hour, I think. And 3I Atlas is coming through at a speed of 60-something kilometers per second. So that's 3 times faster than the average of our local neighborhood, which is telling us that it's coming from a different population from what we have generally around us. Now, Sean will be able to clarify the age dispersion relation in our galaxy, which tells us, which has been discovered over the last century studying stars in the galaxy, that the relative speeds of stars is an indicator of age. Stars that formed older in our galaxy over time increase their random motions for reasons that Sean will explain. And so that's the circumstantial evidence that makes us think that 3I Atlas came from a solar system that had larger motions relative to our solar neighborhood and is older. But it is a circumstantial and probabilistic argument.
So I'm just going to take this opportunity to brag about our telescopes and the James Webb Space Telescope in particular.
Go for it.
This blows my mind. We have data from galaxies closer to the origin of the universe than we have data from rocks closer to the origin of Earth, right? In other words, like if you pick up the oldest rock that we have from Earth, it is further away from the origin of Earth in terms of hundreds of millions of years than the amount of time there was between the origin of the universe and the earliest galaxies that JWST has now observed. And that's part of this story of how well we understand not just the history of our home planet, but the history of the entire universe that it's a part of. And now this is just another part of that story of the local neighborhood that our solar system is a part of.
All right, our last question for today comes from X and asks if we can see grains of sand on Mars. How is the clearest photo we can see for 3I Atlas what we've seen?
So because we're closer to the grains of sands on Mars, right? And so the JWST can only get like these single pixel blobs of the faintest galaxies, the furthest away galaxies in our universe. And because 3I Atlas is in our solar system, we can get the images and the compositional information with JWST. As it got closer to some of the planetary spacecraft Tom was talking about, they can't even see these galaxies, but because 3I Atlas was closer to them than they were to JW, they got really good images of the object as it passed by.
Right, as you said, we can image individual grains on Mars because we have spacecraft standing on Mars.
Right.
But even our closest spacecraft to 3I Atlas, we're still 19 million miles away.
And it's going too fast for us to send something there to intercept and get that close to it. So that's just not, that we just don't have the, if we could, we would, we would be there up close and getting those grains.
All right, well, that's all the time we have for today. Thank you so much for joining us. Be sure to follow.
Okay, I'm just going to do a little wrap up here. So, what they found on it, so they released the images. Some of the images that people have seen, like different globs, or just light passing off of the spacecraft Lucy, being reflected and being picked up, and there's a lot more to be studied and from this. And I just got some preliminary images from Lucy and from Psyche and from different telescopes and from the Mars Maven. Okay, and that's about it. I'm not going to say anything much more about Mikey because I think another YouTuber is going to talk about him later, about an hour of time. And I hope everybody has a good day, and goodbye.